Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to finding derivatives of functions involving inverse hyperbolic functions. So to be able to treat these three cases here, why don't you recall first the definition of or definitions of inverse hyperbolic functions here. So, in fact, these functions are written in terms of logarithmic functions, and they all come with specific domain. So this is sort of like the starting point here. And then once you have like a good grip of the definitions of those functions, please refer back to this table that involves the derivatives and integrals involving inverse hyperbolic functions. For today's exercise, list of problems that we're going to go through. We're going to use the left hand side of this table because that lists all the derivatives of inverse hyperbolic functions. So these are sort of like all ingredients that I'll be using in this video. Please refer back to those time to time because that's what I'm going to do in the video. All right, let's get started. All right, so let's start with part A, but my intention is to do all of them in one shot, and this is a good application of the chain rule, in fact. So please also try to recall the chain rule from calculus. Okay, let's start with part A. We have cosine hyperbolic inverse of 1 minus x, and we have this super cool table here that tells us what the derivative of inverse cosine hyperbolic u is. As you see, it's the derivative of the inner side divided by inner side squared minus 1 in square root. Okay, so u prime divided by u squared minus 1 in square root. Okay, here we go. So first of all, f prime of x is u prime divided by u squared minus 1. Okay, and who's u? Well, u is going to be this guy here, the inner side. So I'm going to call u to be 1 minus x, so that so that u prime, I need u prime here, u prime equals negative 1. There we go. So I have, I think, all the ingredients ready. Minus 1 over 1 minus x squared minus 1, and then this is the radical, right? So I think that takes care of part A. And for part B, we have inverse tan hyperbolic sine 2x. Let me call the u to be sine 2x to start with. And I'm going to go back to the table where we'll grab the derivative of the inverse tan hyperbolic. But I want to first find u prime here. So this is the good application of chain rule, as I was talking about in the beginning of the video. So you have the outer function sine, the inner function 2x. So the derivative of that is the derivative of the outer part times the derivative of the inside, which is 2. The inner part, I mean. So that's 2. 2 times cosine 2x. So since I have u prime, I can go back to this table here and grab the formula for the derivative of tan hyperbolic inverse u. Okay, so u prime divided by 1 minus u squared. So I go ahead and write down that f prime of x is equal to u prime divided by 1 minus u squared. Here we go. So u prime is 2 times cosine 2x, and I have 1 minus u squared, right? Sine squared 2x. Okay? Well, we can simplify the bottom further by using the Pythagorean theorem that cosine squared 2x plus sine squared 2x is equal to 1. Let me just write that down here. Cosine squared 2x plus sine squared 2x equals 1. This implies that cosine squared 2x is 1 minus sine squared 2x, right? So I can go further and write this in terms of cosine squared 2x. Okay. You can also put parentheses here if you want to, if you're feeling safer that way. Okay, So, and you have cosine 2x at the top, cosine 2x in the bottom, but squared. So this square is gone. So I'm down to 2 over cosine 2x. Okay. And that's the definition of secant, right? Secant is the reciprocal of cosine. So you can go ahead and simplify this further. This is 2 times secant 2x. Okay? So we're using multiple stuff here. You could perfectly leave the answer as is at this point here, but remember that like in Calc 1, we're trying to simplify as much as we can because we may use f prime in another calculation. So the more you simplify and the better or the simpler calculations you're going to have at the end. Okay. So the derivative of f prime, the derivative of f is 2 times secant 2x. Okay. And finally, let's look at part C. We have inverse cotan hyperbolic e to the 2x. I'm going to go ahead and call u to be e to the 2x right away so that u prime, this is another application of the chain rule if you want to take it that way. So it's like the outer function is exponential, inner function is just 2x. So the derivative of the outer functions times the derivative of the inner part. So that makes it 2 times e to the 2x. Okay, so good news here is that the derivative of tan and cotan hyperbolic inverse functions are the same. So u prime divided by 1 minus u squared is what we're going to use here. So f prime is equal to u prime in the bottom 1 minus u squared. So let's just plug everything back in. So 2 times e to the 2x divided by 1 minus e to the 2x quantity squared. Okay, that is equal to 2e to the 2x 1 minus e to the 4x. All right, this takes care of part C. I think we're done with all pieces here, ABC. So again, what we used here is the table that I have here for the derivatives and integrals involving inverse hyperbolic functions. So that's all it is. If you have any questions or comments or suggestions, please send those to my way. I'll see you in another video. Bye.